Hello there, taxidermists and gentle peeps. This is Neil Woodman from Digital Taxidermy, taking a little time out of the day to go over a few things to do with modelling. So, we were contacted by a gentleman on eBay who wanted us to print out a model that he had created of the TARDIS from Doctor Who, or otherwise a early 1900s police box, and it's a very nice model, and I'd be happy to print it for him. However, there are a few improvements that could be made and a couple of others that should be made, so that he ensures that he gets what he wants out of it. So we're just going to go through this briefly, so that he has a reference and can make the various changes. So we'll start at the top and work our way down, I think. So we're going to focus on printability, replicability, and also support-free design. So starting with the lamp here, and specifically because you're going to need supports to be able to get this piece at the top here, which is fine. Using supports is not an issue, and he's broken it down neatly into small chunks, so it's not going to cause a major problem. But one of the things that I would tend to suggest is we have these support posts here, which are currently at 1.3 millimeters in diameter. Now, for FDM printing, I would tend to recommend that posts be a kind of minimum of 2 millimeters in diameter, if possible, because it just makes them far more reliable to replicate. There's enough walls in there to make them solid and not to start snapping and bending, etc., causing issues with retractions and that sort of thing. So all in all, the light is okay, but these posts could do with being increased to a diameter of at least 2 millimeters. So the next thing that we have here is the roof section. Now, the roof section, what we have here is very good. It's detailed. The idea of hollowing it out for less material is good. However, this roof part here, the upper section, means that we will have to use supports in order to print it, which means that this entire internal space will be filled in with supports, thus not saving material in the end anyway. So to do that, we can turn this into a supportless design. Relatively simple, and we have some videos about this on our YouTube channel, about bridging and such. But just in the very simplest terms, the hole here in the top is going to print in thin air. This rim here is going to print in thin air, and as such, it requires supports. So we can get around that somewhat. So we have to, let's just move all of these parts to 0, 0, and so in the briefest of ways, we can get a pyramid here. We'll put the pyramid in, and then we will bring it down so it's inside the model. Just check and make sure that that is inside the internal walls there. Fantastic. And then split that bottom. So like so. So now we've filled in that space. So I mean that will print supportless, but it's also kind of handy if you create some sort of a structure to go underneath it, like beams in a roof. Okay, so again, we talk about this in one of our videos about bridging, and we can go 2 millimeters wide, take that all the way across. Okay, and we only need that to be, you know, well, like 0.8 millimeters deep, really. It doesn't need to be incredibly deep to be effective. So we've got that, and then to give it extra support, we can do the same again from the other direction. However, this is the crucially important part, is you cannot leave them crossing at the same height. One has to start slightly below the other, so that it will go all the way across, do a couple layers of that, and then it will start crossing this way. And then you will generate enough support to create smaller grids, which will give you a good base layer, which will get this all handled there. Now, here on these front details, that will bridge. That shouldn't be an issue. There are ways that you can sort of tidy that up, but it's not an incredibly, it's not a big issue. So, but what you can always do is to, if you have a long edge like that, you can sort of tighten it up a little bit by placing a bridge in that is, you know, a couple of layers, so maybe like 0.4 millimeters or something down, just setting it back just a touch from the edge, make that just 1.2, so three walls wide, and you can set that back just a touch from the edge there, and you'll get yourself a little bit of additional support on that front edge, which will just tidy up that front edge there. And it's hardly noticeable, but the ultimate effect on the print, especially if you're going for supportless, is a much neater edge. So let me just group these all together here. If you hear a sound in the background, it's actually just one of the printers clunking away. So the next thing that we have here is these sidewalls. So these sidewalls, again, what we have, so we have here an item. It will print. Now, in general, I would recommend printing it this way on the print bed. But then that gives us a few issues. So again, you will have to use support material underneath all of this to hold it up. So how can we get over that? Well, one way would be to add a couple of additional walls here. We can do, say, 2.4 millimeters thick. So take that up to there. do that. Yeah, we can do that. But we are not done. So that then means we have set a perimeter all the way round, right? Which means that in theory, if these holes weren't there, then that would be able to print supportless. Again, however, we want to provide some sort of additional structure for it to build onto, because if you check the video about bridging, it explains in greater detail with some slice results to show what effect that ultimately has on the way it prints. And then the next thing that we need to ensure is that where these windows are, there is a support here, and also one here. And the reason for that is that if you do not have this, then the perimeters for these windows will be printed in mid-air. So the next thing that you have with making something supportless is these overhangs, and you've got the same thing as you do with having the hole cutouts in this panel. So we can address that by placing in some wedges and such. So for this you can use chamfers, you can use fillets, whatever your design software is. I'm just using 3D Builder here because I've only been given the STL file to look at. This is nice and simple just to play with, and it gives me an opportunity to show you what's going on in the simplest terms. So we place a chamfer underneath these, split like so. So we have ourselves a chamfer underneath that bar, and then all we're going to do is replicate that around of these bits here. So that is fine. Now you're then going to put that here, like so. On this side, we actually have a bit of a difference going on here. So we will want to extend this out a little bit. Just do that for the sake of ease. Now they will actually bridge across, but it will put support underneath this rim, which is good. So the next thing that we are looking at is these bars. And these bars will be treated in the same way as other parts that we have looked at with bridging. Again, see the video on bridging. It's in the tips and tricks playlist. So stick a bridge under here, like so. and all we're going to do is bring this center bar here further down than the other bars. And as I suggested when we were looking at the roof here, it will then allow the printer to bridge across here, create a base, and then these ones can bridge across as well, which will give a nice stable base for that window to be printed. So obviously we can replicate this across to the other window. Something like that. And that becomes a supportless print. Magic. So that is a good way of moving to a supportless print. We can even, if we really wanted to, take this. And what that does is divide the area up so that your bridging takes place over smaller areas, adds additional strength, etc., etc. So that takes care of those panels. So we can just group all of those together. So that approach is an approximation of ready. The next thing that we need to discuss is doors. So we have doors here with hinges. Now, these hinges, so one of the things we need to discuss is tolerance. So we have here a pin which is approximately 3 millimeters in diameter, and then we have a hole which I believe is also 3 millimeters in diameter. So you want to ensure that yeah, 3 millimeters in diameter. So when you are trying to make a joint that is going to be free moving, you want to ensure that there is about 0.2 or 0.25 millimeters all the way round. So in a circular thing like this, it will mean that the diameter is 0.5 mil bigger in the hole than the pin. So the hole needs to be increased in size to suit the pin. The next thing we want to look at is these doors. So this door in itself is, again, similar to the side panels. We can add the same things for bridging and support that we added on the other side walls, which will give us a good print there. The next thing that we can actually consider is if these pins are centralized, then we can in fact increase them in size so that they begin on the base here, which means that when they are printed, the pin will be flat on the base plate, which means no supports required again. So you can those hinge points are not then going to require any support. So making sure that is an option there. You can place those on the base plate, they're not going to then need any support, and you can make the pinholes in the base and top correct to suit. Another option is, which we quite often go for, is to put a hole through and then a receiving hole in the doors, which will allow you to put bits of filament through. So filament comes as a 1.75 millimeters, so then you'll want a through hole in either the base or the door, which will be, what's that, 2.25 millimeters, and then you want something which is a bit more secure in order to hold it. So we often use a template filament plug cutter, which we have created, which provides a certain amount of grip. Now I can just show you what that actually does here. So you can use indentations to provide grip and a tight fit that kind of interferes with the tolerance, but then when you actually press something in, it will grip it, and the tolerance will crush, which will, it won't mean that everything has to be absolutely perfect. So if we just subtract that, we can see in here you get these little nubbins that you can use to secure whatever you place in there. So we have that. So that is a couple of options there, either making the axle bigger or potentially designing to use filament, or you could leave it like that and just use supports for those particular parts. I mean, that's always an option, and it's the designer's choice in this respect. The rear wall, same thing again, putting in bridging here and chamfers behind the bars, and then that will print flat on the base plate again, which is fine. And the base here as well, same thing with the hinges, just making sure that there is tolerance there. So that covers the basic things about design improvements for printing. Now there are also a couple of things that we can consider when it comes to thinking of assembly. So for assembly, I assume you're going to have glue joints down the side here along the top, and that's going to glue to here, and then they're going to glue to here. Now the one thing about 3D prints, about filament prints, is that these surfaces are going to be very smooth. You can sand them and you can get glue to stick to it, but it becomes a very fragile joint. The other thing is alignment. So looking at alignment, you want to make it nice and easy to be able to make it good and square. So there are things that we can do about this. So at its very simplest, we can put a tab in. So we'll put that on the back face, because this face is going to be on the build plate when we print. And we'll just shrink that down. We'll take that to be 1.6. Let's just be generous. We'll make it 2 millimeters. So 2 millimeters thick, which is plenty enough. And then we can put the tab in there. and then we can make it like that. And then what we will do is do a receiver. And again, this is very much in its simplest form here. So you can scale that up to make sure that that is covering that. Bring that one down. Subtract that from there. So what we now have is a tab on that part, and we have a slot in that part, which means that not only will that line up quickly and easily, but you can also put glue in there, and you'll get a nice strong joint that will hold it and make it much more durable. Now, with that as well, you can always play around with doing like what I showed you with the filament plug cutter. So we can make that 0.4, and we'll bring that up. And you create these pinch points, which are like crushable fasteners, and these pinch points, bury that back into the wall halfway, drop that down a touch, there you go, and that they'll apply pressure points, which means that you have your extra tolerance on the hole, but then you can put in a bunch of these to apply pressure to the tab to create extra strength. And if you take a look at some of the other things that I have designed for glueless construction, such as the Ferris wheel, such as the elevator, and various other things, you'll see these being employed in all of the joining systems that I use in those things. So they just apply a little bit of extra pressure, they enable you to get a good tight fit, and also you can aim for glueless construction. So you would repeat that for all of the parts. When it comes to these ones, obviously we placed this part on here. We put the tab in right on the back face of that, which would be along here, and replicate the slot on the bottom. Now you can leave it at that, so you do it on the top and the bottom, so there would also be locating slots up in here. Now you may also want to put locating slots up this side wall here, which you can very well do. Now for this particular one, what I would probably suggest is to use a wedge, and what we're going to do is use something like a fillet, kind of like a fillet. So we will take this like so, make sure that you have enough room. Right, split. Yeah, so you get something like that. You can position it wherever you like. Um, okay, so we've got that. Just copy it. The same thing again is we scale it up just a touch so that the two will slot together. Just making sure that tolerances are good, etc., etc. You can check this in the final design. This is all just very quick at the moment. But again, we group those together. We subtract that, and what you have there is a slot that will go into, which will not only locate it, but it will also enable you to get a good glue joint. There is also potential of adding on the base here, so you could always add some little nodules here, whether you do these as little rounded bars or whether you do them as little spherical lumps. However, there's no hard and fast rules, but you can use these for holding the doors still, basically. So we can set those up like that, so that you have something on the base there, which will allow your doors to not just swing entirely wildly, but they will be held in place unless you physically push them. Think about some of the toys that you've had as a kid, where you have small retainers that when you apply pressure they just push past. Same thing. And also, if you wanted to provide an outer limit so the doors only moved in or only moved out, then you could put a hard stop on the base there as well. So just as an example, again, this is all very quick. I will send this video to the guy who designed this, and then he has an option to edit his design if he wishes, or not. You know, that is also a potential. But we can take this, and we can put that in like that, which will then mean that the door will not open forwards, it will only open inwards, which I believe the doors on this should work like that. The other thing we've got here is that these doors don't quite join up, so maybe that wants to be addressed so that they overlap a little bit. And there's potentially an issue here where you might want to take the corner off of that door. So yeah, you might want to take the corner off of that door just to ensure that it gets past there. And then, yeah, those are the basic changes that I would suggest would turn this from being into a from being a 3D model into a successful 3D print. So those are some things to consider, and those are some design changes to be made. So just in recap, these bars to be made at least 2 millimeters for better replicability. Fill in this hollow space, apply a couple of support beams on the inside, and then that becomes supportless. Take a look at the side walls and give opportunities there, like finish this rim all the way around, place the support beams in, and then add chamfers under the window and a support beam on that crossbar. Same on all the walls there. And then we have the location tabs on the various walls for assembly, and that's on the bottoms and tops and on these sides. And the other thing is looking at the tolerance for the hinge pins there and making a decision about whether they are to be printed with support or without. Excellent. So that is all for now. Just one other thing, I guess, which is for anybody doing design, even if you don't have a 3D printer, as this guy seems he does not, you can always get a slicer such as Cura, and then you can drop your models in. You just get a basic set of settings, and then you can hit slice, preview, and you can take a look at what it looks like when it's going to print. So for example, on here you can analyze and see that without supports this is not going to print out, because these are entirely in mid-air, and you can see that by previous layer, next layer, and yeah, you can see that is just not going to have a good time at all. You can watch the path that it takes. Okay, so that's all for now. So join us again for some more modeling tips. I will send this to the guy who made the inquiry, and we'll see what he comes back with, and we'll go from there. So is there anything else that you would like to see us discuss or talk about, or if you would like us to review one of your models and suggest any potential changes or improvements to make it just that little bit better, then please feel free to get in touch via our email address. You can contact us from www.digitaltaxidermy.co.uk. If there's anything else you want to see, drop it in the comments below. Don't forget to like, share, and if you're really interested, then tell as many people as possible. It really does help us get the word out, and we'll see you in the next one. Bye bye.
Like the video, follow me around, press the bell, it makes no sound. Like the video, press subscribe, I don't know why I am alive.